हो गया. Good evening, student. Welcome back to my lecture. Okay, as you know that today I am going to start wave optics. So, can you type what things have been covered in wave optics apart from Young's double slit experiment, like thin film or Newton's ring, or you can say Fresnel biprism, because if you don't know, then I can repeat this theory. Okay, so I'll just ask everyone, just type it over here that what thing has been covered in wave optics only. Okay, I'm waiting for you. यहाँ पे आवाज आ रहा है. थोड़ा सा रख रहा हूँ. यहाँ पर चलेगा वो देखो तो सुनाई पड़ रहा है. Am I audible? Have a look. Okay, so we are going to discuss, about, okay, what is condition for maxima or minima after interfering of these two waves R1 and R2, okay, and reflection is taking place from air film boundary and then film and air boundary. So here you can see that, that maybe sir has discussed to you also that once the ray is incident and going to the rarer to denser medium. So this is a denser medium because this is thin film. Let me write it over here. Okay. So what will happen? A phase, okay, phase inversion will be there. What is the meaning of phase inversion? Here it will occur a phase of pi. Okay. And once the ray will enter from denser to rarer, reflection also taking place. Okay. Apart from transmission, there is also a reflection over here. We are interested about only reflection. So here reflection is taking place from, okay, a denser medium to rarer medium. So there is no phase change. So there is no phase inversion. So here the phase change is taking of pi. Here I am writing over here, and here phase change is 0, which I have circled. So phase is 0. So when they are going to meet, okay, it's not like Young's double slit experiment where two slits has been given and they are in the same phase. Okay, they are meeting at the same phase. So here phase inversion is there of pi. So condition of maxima or minima will be just opposite of Young's double slit experiment. So what you need to do that to recall this theory, because today I am going to discuss about Newton's ring also, okay, and then some good question based on Young's double slit experiment, okay, where thin film is there which is covered inside the waters. There are so many cases are there, we will discuss about that. But before that we need to recall that what is a path difference, and because of path difference lastly you have to find out what is condition for maxima and minima. So I am giving 5 minutes, you try it, okay. So okay, got it. So here I am writing, first you get the systematically path difference. Here I am writing find path difference delta x for this given situation. If you want, you can give the name like this here, A, B, C. So you have to find out what is the path difference, okay, or how much time does it spend to go from A to C and back. Okay. So try it. Okay, so let's discuss this situation, and what I'm going to discuss now will be very useful to find out the path difference for other system also. Say, what is this path difference? So you can think in this way. So everyone please look at the board. Once the ray is coming over here, okay, and then entering like this, okay, so it is spending certain amount of time, then reflection, and when it comes out over here, then what is the path difference? So the ray that is already reflected, let's see here, so you can have a look how to understand this part. So this is coming over here, and then after reaching over here, it will start reflecting, and then it is transmitting, okay, there is no time delay in transmission, so it will transmit and then reflection, okay, and then again transmission. So once it is coming over here, this ray is gone, okay, already traveled some distance. And how to find out how much extra distance it has traveled compared to this? So as soon as this ray emerges R2, this is the same phase point, okay, you can draw arc like this, this is same phase point over here, or you can think in this way also, okay. So you know that by this rule, primary source and secondary source, these are the, say this is the primary source, then these are the wave form, and all the points over here is working as a secondary wavelet, okay. So all these points are in the same phase, okay. So here, once the ray is over here, so you can think like this, that once I draw the arc over here, this distance is, say I have given a name n, and let me join this and give me this name as m, okay. So what is the path difference here? Okay, we need to understand this point. So total path difference will here, delta x will be equal to this much distance in thin film. So what is the distance in thin film? AB. But you know that sir has already discussed what is called air path length, okay, or how much in thin film the distance look like AB, but in air it will be bigger than that. And how much is that? Mu times AB. So this is the air equivalent path length, okay. So multiply with mu, okay. So we are going to solve some question based on this concepts only today, that once the ray is traveling AB in some medium mu, then the air equivalent path length will be, okay, mu times AB, which has been explained to you. So here the overall, okay, the path difference will be AB, mu times AB plus BC, and it's already in air, this point you can see AN. So this is minus n is very, very crucial over here, okay. You cannot only think like this, that it has come here and reflected. Once it is reaching here, these 2 points are in the same phase, this point and this point. So after that you have to take the difference over here. So this is the path difference. So now we need to find out what is AB plus BC. It's not very difficult, okay, minus AN, okay. So you know that here this distance, this is T, BM equal to T. Have a look. Okay, BM equal to T. This is R angle of refraction. So cos R will be equal to, if you look at this point, you can calculate AB. Cos R will be T upon AB. So AB will be equal to T by cos R. Okay, so we have calculated over here, okay, and then you can substitute the value here, mu times T by cos R plus T by cos R minus AN. And how to calculate AN in this case? You can look at the triangle, in triangle ANC, this is 90 degree, okay. So this angle will be how much? I. Have a look how this is 90 degree minus I. If this is I, this is 90 degree minus I, this is 90, so this will be I. So in triangle ANC, sine I will be equal to AN by hypotenuse, which is this one, AC. And AC, how to get AC in this case? So you can take the formula over here, tan R, you can look here, tan R tan r is given by am divided by, okay, this t. So am is t tan r. So that implies AC equal to 2 times am. So 2 times 2t tan r. Okay. So here it implies an equal to, okay, AC sin I, and AC I have calculated over here, which is 2t tan r into sin I. Okay. So we'll write over here 2t tan r sin I. So you can start from here, part difference, and then geometrically you know how to solve this part. Now here sin I, as you know that everything is in terms of r, so we'll also convert I in terms of r by using a Snell's law over here. So Snell's law I'm going to write over here, 1 into sin I equal to mu into sin r. So in place of sin I can write mu sin r. So this becomes, okay, 2 mu t by cos r, 2 mu t by cos r minus 2t tan r into sin I, from there is, okay, mu sin r. So you can have a look, this is sin r by cos r, I can write next step. So here I am going to take the common 2 mu t, 2 mu and t here, 2 mu t common over here. So this is 1 by cos r minus, okay, and this is sin r by cos r into sin r, which make it sin square I by cos r. So take the LCM of this. I'll just okay. Here I'm going to write. So this becomes 2 mu t cos r 1 minus sin square r. So delta x will be given here. I'm just going to write over here again. Delta x will be given by 2 mu t into, okay, cos square r by cos r is cos r. Okay, so this is cos square r, 1 cos r cancel out, cos r here, 2 mu t cos r. So this is the very important formula, and in exam you should, before examination hall, going to examination hall, you should memorize this formula, 2 mu t into cos r. So we found what is the path difference. I'll change into phase difference and maxima and minima. First you note it down if you have not noted, okay, and then I will go further. I'll just explain the theory related to Newton's law, Newton's rings. Okay, all right. Did you understand this point? Okay. So now I'm going to write what is the condition for maxima and minima. Okay. So this path difference 2 mu t cos r, okay, this much up to here, okay, plus lambda by 2. Why am I adding this lambda by 2? Because here phase inversion has taken place. Because the ray is coming from rarer to denser medium. So pi phase means equivalent path length is lambda by 2. By this diagram you know that, but still I am drawing that this is lambda, this is 0, this is pi, and this is 2 pi. So once you go pi phase ahead, the length will be half of this lambda by 2. So this is lambda by 2. So total path difference plus lambda by 2, okay. Now this becomes total path difference, okay, because inversion has taken place already. So overall path difference will be this. So delta x is not path difference, that is just okay, to calculation from A to B, B to C, C to N here, okay. So now we'll try to find out here what is the condition of maxima. Already 2 mu t cos r is there plus lambda by 2 because of phase inversion, okay. If it is equal to plus minus n lambda is condition for maxima. So bright fringes will be formed, and once you are going to solve this further, you can write like this: plus minus, just let me write n lambda, okay, because minus means the fringes will be upward direction as well as downward, so it doesn't matter. So here if I am going to take here lambda common, which is equal to 2n minus 1 into lambda by 2. And this is the case for maxima. In Young's double slit experiment, it used to for the condition for the minima. So this is equal to 2 mu t cos r. So this is the condition. Okay. So once it is given that, find out what is the first maxima or second maxima. Okay, so for first maxima you can keep the value n equal to 1 over here, okay, starting with 1, otherwise this number will be negative, and this will become lambda by 2. Similarly, if you are keeping here 3 lambda by 2, 3 here, then 5 lambda by 2. And then here T, film thickness has been given, mu is given, R will be given to you in this case. If it is not given, certainly I will be mentioned to you. Okay, so by this way you can find out what is the thickness of the film or mu value, whatever they wanted to know, unknown, you can solve, but this is the basic that you should remember. And for maxima, for minima, here you have to write n lambda plus lambda by 2, this will be cancelled out. So 2 mu t, so just I am writing over here, just rubbing this. For minima, 2 mu t cos r, okay, equal to, now plus lambda by 2 is n lambda plus lambda by 2, or generally you write, okay, can you recall this? Okay, so here lambda by 2 is cancelled out, so 2 mu t cos r equal to n lambda. This is the condition for minima. Okay, so destructive interference will take place here. There will be a dark fringe over here for this given condition. Okay, apart from that, you should also know here that for normal incidence, once the ray is coming normally over here, some part is reflected R1, and as you know that normal direction does not deviate, so this will be R2. They are very close to this, but I have shown you like this, R1 and R2. They will interfere, and the condition here change for maxima will be 2 into cos r will be 0. You can have a look, because if I is 0, so by Snell's law r will be 0, cos 0 is 1. So in this case it is 2 mu t upon 2n minus 1 lambda by 2 for normal incidence. Okay. So these are the conditions. Okay, quite simple. Okay, so once they are giving this kind of question, okay, you can quickly okay, derive the equation and you can find out the condition based on that. If they are asking find the thickness of the film such that fifth maxima is formed, say they have given this question. So if you have to find out what is the thickness of the film for normal incidence over here, for fifth maxima, here you can write 5. So it becomes 9 lambda by 2, lambda will be given to you, mu will be given to you, mentioned to you. So thickness you can find out. Okay. So this is the thing that you should know, okay, how to derive it. If there are any question, you can type it over here. After this, we are going to discuss about, okay, what is Newton's ring. Okay, justice for Okay, so I think some member is disturbing us. I think maybe not, they are not a part of CL also. So Praveen has blocked them, by the way. And those students who are interested in my lecture, please type it here. Did you understand this concept or not? Okay. Okay, so that I could go further. Okay. Because there are advanced based questions are these days, I mean, very much from this chapter only. Okay, wave optics. So like this time they have the weightage was almost 16 to 17%. Okay, so that's why I wanted to cover this extensively, this concept. Okay, so should I go ahead? Should I go for Newton's ring once you have understood it? Karan, Coulomb's law now. Karan Solanki. Sanjeev, where is Ruchik and Dev, all this person? Okay, all right. Do you know this Karan Solanki is asking Coulomb's law at random? Okay, I see it. Okay, so here block. All right, now Newton's ring is also a concept linked to thin film, but in place of thin film that has just now we discussed about that, is a air thin film has been used. Let me tell you how. So basically, for this experiment, okay, you will be provided one plate made of glass, maybe crown plate, and then okay. So how to do this experiment? It's quite simple experiment, okay, but you need a microscope to see the rings in this case. You cannot do only take the plates and lenses and you can see the Newton's ring, okay, because the radius is very, very small and our resolution of eye is not so high to see them clearly. So you need a moving, okay, telescope in this case. So here we will place one plano convex lens, okay, over here having value mu. So you can see that here the air is trapped. Just I will write it over here, which is a concave lens. You can check like this, it look like this here, concave lens. Okay, once you remove this, so whatever air trapped over here, okay, this plays a very, very important role to produce, okay, ring here around that. But what is the phenomenon and what is the derivation for that? Once you understood the concept of thin air film, you understand it better. Okay. So basically in Newton's ring, the ray that is being incident over here, say normally or at some angle, for time being I'm just taking normal incidence. Okay. This will enter over here without any deviation. Okay. And then after that, okay, so here ray generally taken, okay, parallel, okay, for this we use one more lens, and at focus we keep a light source, monochromatic light source. So what will happen in this case? That this ray will become parallel. All this ray will become parallel. Okay. So this is the way to incident the parallel rays over it. And since it is a plano-convex lens, so it's a normal incidence there. So I'm just rubbing this part. So in this case, it will meet first. Okay. Here, a boundary over here. You can see that this is a glass air boundary. That glass air boundary, if the ray is being reflected from here, say R1, being reflected over here, then phase inversion will take place, because phase inversion will not take place because the ray is going from denser medium to rarer medium. But once it is reaching over here, say after refracting, after something like this here, okay, now the ray is moving from air to glass, so it will be reflected. Okay, just something like this here, and extended over here will make a ring over in this case. That diagram is not so important, just you need to say that there will be two reflection will be happen, one at glass and air boundary, and then again air and glass boundary. Here it is a plate actually. So now phase inversion is taking place not on the first surface, this glass to this air, but here air to glass. So again it's some same concept like thin film, where just one inversion is taking place. So the answer will be not same as Young's double slit experiment. But we need to find out what is the path difference. Because once the ray that is being reflected from here and that it is being reflected from here, there will be a path difference, and how to get this path difference. So we are going to discuss about that. In fact, this theory has been explained before also. Just I need to remind you that how to solve this. You can draw a line like this. You try it by yourself. So I'm drawing this lens over here again. Okay, and then this is a radius R joined with this. This is thickness T, say somewhere. Okay, so wherever you are saying, say this is thickness T and T is variable, you can have a look. So these are the thickness of air film. This T all are variable. So just take one case of this anywhere, okay, like this here thickness, and then here one you can draw like this R. Okay, so I'll just consider a center of this ring, a center of this lens, join this. Okay, this is thickness T. So here I am considering, okay, and then join this part again R. This is also R. This is R. This is T. So you can get a correlation between them. Okay, say this is radius R and this thickness is T. Okay, this is T, then this will be T here. This will be R. This is total R. So this is R minus T. R minus T. This is R. So let's get the correlation. So I don't need to draw this diagram. You can understand from here itself. You can write like this here, that in this right angle triangle, okay, R minus T the whole square, R minus T the whole square plus R square, where R is the radius of that ring where thickness is T, okay, equal to R square. Check. In this right angle triangle, this R minus T the whole square plus R square equal to this capital R square. Solve it further. Okay. So as you know that T is almost negligible over here. Okay, because the air that is trapped inside this have the height of order of few micrometer or millimeter. Okay, so that can be neglected because square quantity will make it more lesser. So T square is neglected. Don't neglect T here because it's a linear term. So this 2RT equal to R square. So here you can calculate what is the thickness. Okay, R square by 2R. So we calculate at thickness T what is the radius R. This is the correlation between them, T and R. So it's an important point over here. Okay. As you are going further, here T keeps on increasing, so R value also keeps on increasing. So there will be a different radius at different thickness. And finally you will realize that here a ring is formed over here of different radius. Okay. So these are dark fringes, and in between this is bright fringes. It is seen on the this flat surface over here. So this, the diagram that I have drawn, it is seen on this flat surface edge in this case. So this is the correlation between them. Okay. So to calculate here what is thickness T and radius R, okay, I think in class 11th you have been discussed spherometer. Do you know the concept of spherometer? So you can recall the concept of a spherometer where there is a formula between, okay, thickness T and radius R. Okay. Mainly this T in your book has been mentioned in CBSE book, practical book, as H. Okay. So if R and this H has been calculated, you can calculate here what is the value of R in this case. I mean what is the radius in this case. Okay. So now we will write the condition of, so in, if you want, I can just quickly give a overview of say spherometer. In a spherometer, actually you have seen that there is a device which can measure the thickness of the lens, and once you know the thickness of the lens, you can calculate radius of curvature. And how to do that? You might have seen, maybe if you have not done this experiment, you can get the diagram of spherometer at website, at any, you can search in Google, and there are three, okay, like tripads. Okay, so you keep on the lens, okay, and there is a screw, and then you can just move it down. Okay, you can calculate over like this here. Okay, so say this is a lens. Okay, and then these are the legs here. Okay, and third leg is somewhere here behind. So I draw a dotted line, and this is kind of spherometer, and this is the screw which is measuring the height, kind of this. Oh, I should have meant to draw an arrow over here. This is H. Okay, this three legs anywhere makes an equilateral triangle, something like this. Okay, let me tell you what. So keep this tripod, or you can keep this spherometer, okay, on the lens, and mark those 3 points, and you can measure the distance between any 3 legs. Okay, so once you, how to measure the distance between any 3 legs, just you need to mark those points. Okay, remove that. Okay, and then you can measure it by the scale over here. Say this distance is A. So here it is like this. So 1, 2, one leg is hidden, you cannot see, and this is here, another one. Okay, so there are 3 legs over there, and this is the points. This point I'm talking about, one is hidden over here, and this point, this one is a screw, okay, which can move up and down, okay, to measure this thickness in this case. Okay, so you can have a look all this point. So this is somewhere here, since it is equilateral triangle. So this is the median, okay, passing through that here. So this is known as H. Okay, this is known as A. So you can calculate what is this distance. Once you are able to calculate this distance, you can have a look like this. This is H, and this is, say, A, total A, like this triangle, and this is H over here. Okay, so how to calculate the value of this A in this case? So if you are able to calculate this is H, okay, height, you can measure in this case, and this is known to us as radius R. So I am going to draw this diagram again. You can take the help of this. This is R, this is H, so this is R minus H up to here, and this is how much? So this is the distance between the 2 legs, say A and B, where AB equal to A. Here I have mentioned ABC. Okay. Now, how to get that? You know that how to solve this point. Once you come to know what is the value of this, the question is solved. Okay. So, what is this length of the leg in this case? Don't think it is a diameter of the, it's a diameter of the lens. It's not a diameter of the lens because tripod is small. It can fit anywhere on the lens edge in this case. So, this A is totally different than the diameter of the lens in this case. So, how to get that point? R minus H, this is H given over here, A. Now, you can use the simple geometry like you have studied in class 10th, that this is the median. So, it will intersect in 2:1 ratios. And this length you can calculate, say CM. Okay, this angle is 60 degree and this side is A. So, this is A sin 60 degree root 3A by 2. So, CM is root 3A by 2. Correct? And then you can divide into 2:1 ratios. So, 2:1 ratio. So, if I wanted to know what is this height in this case, so this will go in 2/3 part of this. Okay, 2/3 because this is 1:3. This is 2/3. So, overall, this length will be equal to this. This length will be, this is 2/3 of total length. You can have a look. It's passing through the median. Is given by A by root 3. A by root 3. So, this is A by root 3, this is R minus H, this is R. Similar like this, you can write the expression over here as R minus H the whole square plus A by root 3 the whole square equal to R square. R square plus H square minus 2RH plus A square by 3 equal to R square, cancelled out. Okay. So, here is the value of A or H you can calculate over here. So, if I think in your school book they have calculated the value of R here. So, 2RH is equal to H square plus A square by 3. Okay. And then here R will be given by H square by 2H plus A square by 3 into 2H. It becomes A square by 6H plus H by 2. I don't think that this derivation was given in CBSE class 11th book, but you can see it's quite easy to understand. So, I have given you the proof of that, because these days in JEE Mains also they are asking question based on your practicals book. Okay. Now, as I told you that here T is equal to H. So, once you measured the value of H, okay, through a screw gauge looking like that, okay, if you are finding by spirometer this screw, okay, by the movement of this screw you can measure the thickness T or H in this case, then you can calculate the value of R, because you know the distance between any two legs of the, okay, spirometer. So, using this correlation, you know that once you know the thickness or H, you can calculate R. Once you know R and thickness over here, you can calculate the radius of the Newton's ring in this case. Okay. So, I'll just you can note down this. If you have any question, you can ask. Okay. And in between, you can have a look that if you have any problem or any doubt, you can, before I could give you what is the condition for maxima minima, let me know if you have any difficulties. Okay, so now we'll see, once we know thickness T, okay, then what is the condition of maxima and minima in Newton's ring. So Newton rings, as you know, that it is looking like a concentric circles, okay, of dark and bright fringes. Okay, so here to find out what is the thickness of thin film of air over here, say like this T here. Okay, so just now I have derived that for normal incidence of light, okay, on thin film, the path difference was 2 mu 2 cos r, but here r is 0 degree, so 2 mu 2, and here mu is actually air, so mu air is 1. Okay, so it becomes, thickness becomes 2T only, because this is equal to 1. So I am taking the help of thin film of the, you can say that this is a thin film of thickness T. Then what is the correlation of path difference? Path difference is 2 mu T cos r, r is 0 degree, so it is 2T, because mu a is equal to 1. So 2T plus lambda by 2. 2T plus lambda by 2. Why am I adding lambda by 2? Same explanation that I have just given in thin film, that it's a phase inversion of pi, that's why lambda by 2 you need to add. If it is equal to n lambda, it will be a condition of maxima. So condition of maxima, and here 2T can be written here, you can take the help from here. 2T is equal to r square by r. So r square by r equal to n lambda, here in place of this, minus lambda by 2. Okay, same, or you can write in this form. Okay, so finally 2n minus 1 into lambda by 2, directly you could have written also r square by r. So here r is given by under root, okay, 2n minus 1, okay, lambda by 2 into capital R. So once you wanted to know what is the radius of fifth bright fringe, 5b I am writing, okay, you just need to write here n as 5, so it becomes 9 into lambda by 2 into r. Lambda and r will be mentioned to you, so you can calculate what is the radius of fifth brightness. Okay, so if it is not given here r, I told you by spirometer technique that you can calculate once the height thickness is given to you. You can use this formula to get the answer of r in this case. So quite useful. Okay, so they can mix up this problem also, because this is in your syllabus. So by this way we come to know what is the radius of any bright or dark fringes. And for dark fringes is quite simple here. Only simply over here is n lambda, r square by r equal to n lambda. Okay, because this is n lambda plus lambda by 2 cancel out. 2t is n lambda, and keep the value over here. So here, if it has been asked what is the radius of dark fringes over here, you can use this technique, r square plus r plus lambda by 2 is n lambda plus lambda by 2. This is cancelled out. Okay, this is for dark fringes, dark. Okay, so this much easy is this. That's why I have discussed that. Okay, theory. Rest theory has been discussed with you. Okay, so we will take some question based on Young's double slit experiment. Okay, if you want, if you have any other, I think you just need to tell me whether it has been explained what is the interference because of thin lenses, like there is a lens and it has been cut into two halves like this, and main source has been kept over here. This will also produce the interference patterns on the on the screen. So this two system I have already discussed: thin film, Newton's ring, and third one is here split lens method to find the interference in this case. If it has not been explained to me, you can type it over there. I can explain this to you. Okay. Yeah, Parv, it's important because this is given in your practicals book. So it's not very difficult also. So I had given the proof also. क्लास में। Okay, there is a question. First, let me draw the diagram. Okay. So there are two slits, S1 and S2, and on the principal axis and main source has been kept like this. This is mentioned as 1 millimeter. That is small d. Okay. And the distance of this is given as 1 meter. The distance between the main source and two coherent source. This is the screen that has been being placed. Okay. And they have written here as y-axis. This d is 2 meter. Okay. Now they have mentioned also a point P over here. P is a point just in front of the slit S1. So here I am going to write the question. In a modified YDSE Young's double slit experiment, the source S of wavelength (5,000 angstrom) oscillates about axis of setup according to the equation y equal to 0.5 sin pi t, okay, where y is in millimeter. So this y is given in millimeter. Okay. A. Find the position of maxima as a function of time. Okay. B. At what time t will the intensity at P a point exactly in front of slit S1 be maximum for the first time. So you can see that's a very, very conceptual question, because it's not an ordinary question of YDSE, it's a modified one where this source S is oscillating. You can see that according to this the amplitude is 0.5 mm and this is 1 millimeter. So this is oscillating between these two. Okay, so it's a oscillating. Okay, so this is the oscillation between these two. So it will oscillate like this. And because of this, here maxima position will also keep on changing. So you have to find out the position of the maximum as a function of time t, and also you have to find out at what time t will the intensity at P, where P is in the front of S1, okay, will be a maximum. I mean intensity will be maximum for the first time. Okay, so how much? Because first time why they are asking, because it keeps on repeating. So after a certain amount interval of time, intensity at P will be maximum. Okay, so you have to tell me the first time when you are getting the maximum intensity in this case. So you try this question. It's a very good question. Okay, I'm giving you 5 minutes for this. Kunal is asking some question. Okay, if S oscillate with some frequency, will that affect the wavelength of light emitted to? No. You know that Kunal, you know that the frequency of the light is too high. How? You think like this: V equal to F lambda. In place of V, you can write C equal to F lambda. Okay. Say you take the example of visible light, say red color light. So red color light has angstrom around 7,800 angstrom. Okay, even if you take it at 10,000 angstrom, okay, you can find out what is the frequency. C is 3 into 10 raised to power 8, 3 into 10 raised to power 8 divided by 10,000 angstrom. Okay, so you can have a look that how frequency high. It's order of 10 raised to power 14. You can check. So of course this oscillation frequency, okay, cannot be compared with the frequency of the light that is being emitted. Okay, good. Any other question you can ask? P is actually not at P, it could be anywhere. Okay, I'll do one thing. I'll just give you a little bit hint. Okay, so that you could solve it easily. See, you have to be ready with some data which can help you to solve the question quickly. And one of the important thing that you should remember, I think you know that, but still, okay, I'll come back to this. Say this is any point P anywhere, not in front of the slit S1 and S2. Okay, so if the slits are very close, and you know that they are of millimeter order, so in reality they look like this. This is the two slits. You can have a look. Lesser than this also, which I have drawn. Maybe you cannot see also. So once you draw this diagram and say this is the point P, and I am going to draw it, it will be very difficult for me to draw this line because this slit is very close. So I'll do one thing, just have a look. Have a look here. So this S1 and S2 is very, very close, lesser than this. So once you draw an arc line over here, like sir has told you, it is considered a small, it's like a perpendicular line. Why? Because of this diagram. Okay, because this gap is very, very small. So this distance is called path length delta x. Okay, so it has been already explained, but still I am giving you an expression which will help you to solve this question mentally also. I told you. Okay, so now here this is D, and say this angle is theta. So what is angle theta? So as I told you that if these two slits are very close and this is the point P anywhere on the screen, you join these three lines, two slit, and in between there is center line here. Third one is the center line. Okay, I cannot draw the straight line because it's very difficult for me. So here you can have a look that if this angle is theta, so this will be theta, and so this will be also theta. So all this angle will be theta. This one from here also, this will be theta, and so this one will be theta. Why? Because of this diagram, because they are very, very close to each other. So this approximation is always taken in Young's double slit experiment. So even it is not given and it's mentioned that it is Young's double slit experiment, you can take this approximation that this theta can be taken from anywhere. Now, if this is theta over here, so if this is theta over here, say, then this is 90 degree minus theta. This is 90 degree, so this will be theta. One thing is theta in this case, this is D, so this will be delta x will be, path difference will be, okay, D sin theta. Correct? So you should know that, you should quickly memorize this formula that the path difference is given by, okay, D sin theta. Now come back to this. What is sin theta here? So as I told you that if this is theta, this is also theta, this is also theta, all this value is theta. Okay, because this gap is less. So here tan theta is given as y by capital D. This is capital D. Okay. So if this point P is very close to this screen, okay, until it can follow this condition, sin theta equal to tan theta, which you know that up to 5 degree, almost 3 digits are matching. You can check the sin and tan table. Okay, so up to 3 degree here, okay, you can say that sin theta is almost equal to tan theta. After that, some differences start coming. Okay, so here you can think in this way. So what is the limitation of this formula? You cannot always write D as D into, and sin theta I am replacing it by tan theta, because I am assuming that, like it has been explained to you, sin theta is equal to theta, tan theta equal to theta. Up to 4 to 5 degrees they are, up to 3 digits they are equal. After decimal 3 places they are equal. So this will be D into y by D. So path difference is given by D by D, remember in this way, this distance D upon capital D into y is the height of the point, okay, is known as path difference delta x. So this is the way to memorize path difference, but it has certain limitation. You cannot use this formula always, because you cannot say that tan theta is equal to sin theta. If it is mentioned that, okay, this point P is not at up to 5 degrees, say 30 degree, it is at 30 degree, 40 degree, 60 degree, more than 30 degrees, say, then you have to convert this, like delta x you wanted to know, then you have to write d into sin theta, correct? And you can convert here tan theta into sin theta by this formula. If you wanted to calculate exactly what is path difference, I am telling you how to solve this. So I am telling you the limitation, okay, up to which limitation you can use dy by d, still sin theta equal to tan theta. If it is very far away, this P point is say more than 30 degree, okay, or more than 5 degree also you can say. Then in this case tan theta is given by y by d, so this becomes under root y square plus d square. So d into tan theta, and now sin theta directly you can write like this here, sin theta in place of that is 1 by y by root y square plus d square. Okay, so this is the path difference when sin theta is not equal to tan theta. So I have seen many times students only remember this dy by d is the right answer. I mean, not always. Sin theta is matching with theta, then equal, otherwise you have to use this. Here I have given you a derivation in this case. So once, say this source, so I am just writing here as d1 as 1 meter, this I am writing d2, okay, is at distance say y, this is y distance, okay, so it is oscillating between s to s1 like this, up and down, because equation I have given to you. Then once you join this here, this two, ss1, ss2 to any point P, not necessarily in front of this, because I am generalizing it. So this is, since I have taken this as y, so I am taking this as y1. We will discuss about that, how to find out path difference, how to write it mentally in one step. Okay, since I have explained here, so you can take the help of this. This part is quite easy for you to find out what is the path difference between S2P and S1P. This is given as D. Okay, so this will be, looking at this, just now I explained that what is the form that is coming out to be d into y by d, you can use it, okay, if P is close to this point. So I am assuming that this P is very close to central bright fringe, CBF. Okay, then now I am rubbing this. In this case, okay, because in exam you know that you have to write the expression quickly. You don't have time to derive all this thing again and again. That's why you should think in that way. First you take this half part, and you wanted to know what is total path difference. If you are looking at this, the path difference actually will be, okay, equal to S1, okay, or SS2 plus S2P minus path difference equal to SS1 plus S1P. And if you want, you can split into two parts like this, quite convenient for you. Okay, SS2 minus S1, where SS2 stand for, okay, path difference just before the slits, and this is after the slit, before and afterward I am using. Okay, how to get that? It's not different than this formula. You can use this formula directly. You can think in this way. First I will explain S2P and S1P. D, as you know that d by d, here I am writing d by d into y, height of this point is y1, so this is y1. So no need to draw a line like this and then calculating what is path difference, angle and everything. Okay, forget about that. Directly you can say like this, the path difference will be, if I know this is y1, this point is at height y1, and I wanted to know, calculate this SS2, S2P minus S1P, I will directly use this formula, d by d into y1, because proof I have already given to you. Similarly, if you look at this point here, half part here, is same like this part, okay, just it's a mirror image you can say. Now this height is y from central bright fringe, like this is at height y1, this height is y. So you have to find out what is SS2 minus SS1, okay, the similar formula here will be d by d into y plus. And if you wanted to calculate for delta x for central bright fringe, Okay, you know that what is called central bright fringe, where path difference is 0. So delta x is 0. You can easily calculate what is the equation. So got this point, limitation and everything. So now you can solve this question easily. So this is the way to write this. Few question I'm going to take also where you can write all this formula directly. Okay, so let's complete it. Okay, so this is the path difference, and I told you how to write this quickly, but assumption has been taken clearly that P is very close to central bright fringe. Otherwise, you cannot write this. I had given the modified formula also. Anyhow, now this will be, we have to calculate here, okay, what is the value of y1, because this P is the position of CBF which keeps on oscillating also. If it is going up, then it is going up, coming down, then it will come down, and so on. So it will start oscillating between a certain limit. Let's see what is the maximum height it can go up to. So here d by d y1 equal to minus d by d into y. So this y will be, I should have written here d1 because you can know, just I missed that point, okay. So here if it is y d by d1, this is d2 because this distance is not given same over here, that's why. Okay, so just this point you need to correct. Okay, so y1 will be minus d1 by d2, okay, into y. Okay, check. Correct? Or this is d2. Now it's right. Minus d2 is 2 by d1 is 1 into y value is given as I think 0.5 sine pi t. Okay, you can check it. So it becomes minus sine pi t. So maximum it can go plus 1 to minus 1 this value. Okay, so this is the equation of, in terms of time t, of CBF. Why CBF? Because I have taken path difference as 0. Solve the second part now, B part by yourself, and after that we'll take break. For second part, okay, we will just have a look over here. Delta x equal to d by d1 plus all this value has been given. You just need to substitute the value. Okay, d I think is given as 1 millimeter. Okay, d1 was is written over here 1 meter. I'm converting into meter into y. Y is 0.5 sine pi t. Okay, this is meter, this is in meter, so this is in millimeter. You can have a look, 0.5 millimeter sine pi t plus d by 2 into y1. Now they have given that this y1 is equal to, actually p point is in front of this. So this is nothing but d by 2. This distance is d by 2. So in place of y1 you can write here d by 2. Okay, so here I am writing d by 2. And d is given as 1 millimeter, I mean, by 2. Okay, so this is d by 2. Correct? D. So this is the part difference in terms of millimeter. You can check. Okay. And if it is equal to n lambda, lambda was 5000 angstrom, so you can change into millimeter also. Okay. So I will do one thing. I will just write this as 5000 angstrom. Okay, and we will convert it into the same unit so that you could solve this question. Or if you want, you can write this as 10 raised to power minus 10, and this is, okay, this millimeter is changed already. You can check. Okay, correct. So now everything is in meter. Am I right? So minus 3, 10 raised to power minus 6. This is 10 raised to power. Oh, this also I need to change. 0.5 into 10 raised to power minus 3, 10 raised to power minus 6. So this becomes 10 raised to power 7. So n into 10 raised to power minus 1. Okay. So 10 raised to power minus 6 here. Okay, will cancel. I'm just going to write as n into, this is 10 raised to power minus 10, 10 raised to power minus 4. So this become 0.5. Correct? And here all these are cancelled with this one. Just let me cancel all this. 10, and I will just write here 10 raised to power minus 6. Okay. So this becomes 0.5. Okay. 1, 2, 3, 4, 0.5 into n equal to, this becomes 0.5 sine pi t plus 0.25. Okay. Even you can cancel this 0.5 with this 0.5. So this becomes n equal to sine pi t plus 0.5. Okay. So sine pi t equal to n minus 0.5. This is the generalization. And to be first time minimum could be, time will be minimum depending on n. Okay. Here I am going to take n minimum value as 1. So if I am taking n as 1, then it becomes 0.5. So here time will be, which is half, which can be written as sine pi by 6. So pi t equal to pi by 6. Pi cancel. So t is 1 by 6 second. This is the time t when first time p will be in front of slit S1. So this was very useful formula that I have explained. Okay, you can use this directly in exam. Okay, so we'll take break now. Okay, and 15-minute breaks from now, and then we'll continue with some more problem. Okay, so welcome back. We'll take another question based on Young's double slit experiment. Question is, drawing a diagram over here. Say this is a vessel ABCD. The distance between S1 and S2 is 0.8 millimeter mm. This is main source. This is 40 centimeter below. This is 2 meter. Okay. Okay. Here is question. A vessel ABCD of 10 centimeter width has two small slits S1 and S2 sealed with identical glass plate plates of equal thickness. So in this diagram it is not shown, but I am just going to draw one glass slab, identical glass slab of same thickness. Okay, over here. Okay. The distance between the slits is 0.8 millimeter. POQ, that is this line, POQ is the line perpendicular to the plane AB and passing through O. The middle of the middle points of S1, S2. middle points of S1 and S2. Okay. Monochromatic light source S is placed 40 centimeter below P and 2 meter from the vessel. Okay. What you have to find? A, calculate the position of the central bright fringe CVF on the other wall CD, on the other wall CD as shown in the diagram. Okay. B. Now a liquid is poured into the vessel and filled up to Q. Okay, just filled up to Q such that OS1 is still exposed to air. Okay, the CVF. Okay, the CVF is found to be at Q. So now CVS shift to Q. Okay. Calculate the refractive index of the liquid. That is mu, you have to find out. Okay. And how to find? Because it's given that once it is poured, water is poured up to OQ level. Okay, whatever the CVF was there, okay, is found to be at Q now. Okay, so it's still it's a very conceptual question. You need to try this now. Okay.
Thickness of slab has not been mentioned. They are equal thickness. So CBF, the formation of, I mean the position of CBF here will not change at all. Like you know that, I will explain this, but for the time being there is no thickness mentioned here. And that slab is just fit in because so that if water is being poured, it does not leak out. Okay. Just to stop the slits S1 and S2, this glass slab has been used. Okay, so I'll discuss this question. See, once what is the effect of this glass slab, okay, on the slits? Let me tell you first. See, it is covered with this glass slab having same mu, it's not given here, and same thickness T. And this is the, if the source is placed here, just in between that, you know that CBF will not change, it will be here. So once main source S is here, okay, and this is the screen, this is CBF. Now why, like sir has told you that once you are inserting a glass slab over here, the fringe will go up. If you are inserting over here, it will come down. Okay, so clearly he has told about this. Okay, if both has been covered by the glass, okay, depend on thickness of the glass and mu, it can, whatever the dominant is there, like say this thickness is T1 into mu1 minus 1, like sir has told you this is the part difference. and minus T2 upon mu2 minus 1. So this is the delta x. If this is T1, this is mu1, this is T2, this is mu2. If this is positive, this CVF will go up. If this is negative, the CVF will come down. And if it is equal to 0, okay, that means CVF will remain same. Now consider this case. Here it's a given that identical glass, that means mu is same as well as T is same. So you can have a look that this term is being cancelled. So there is no part difference. So CVF will remain here itself if main source is placed here. So now I told you that there is no effect of this glass plate. It's irrespective of mu and T, this will be cancelled out, and so it will not create any part difference. Clear? Okay. Now let me discuss about this question. Okay. So here the part difference will look like this. So this is point P I am considering. Okay. And another is this. Okay. So this is S1, this is S2, and this is main source over here, and it is being pulled down, so P will go up, CVF will be somewhere here. You know that here S1, S1P and S2, S2P, okay, the part difference is 0 because this is CVF is shifted from here to here, because it's kept, if you are keeping over here at P position, CVF will be at Q, okay, it will be at Q, but once you will pull it down, it will go up. So what is the part difference here, delta x? Just now explain that it is SS1 plus S1P minus SS2 plus S2P. I should have written either way because this could be longer, but I don't know, so here I am just writing in this way. You can have a look this once you are taking this together. Okay. So you can keep this terms before, okay, because clearly here SS2 to S2P is more than SS1 to P, that's why it's gone up, CVF, to maintain this. This length is longer than this, that's why it has gone up. So I'll just correct it. I'll just write this as first SS2 plus S2P minus SS1 plus S1P. Why I'm doing that? I told you that this path must be longer to compensate that it has gone up. Okay, so this term is more than this. Okay. Now calculate the position of the CVF on the other wall of CD. I am taking this as P, and I know that part difference, this must be equal to 0. Do you remember last time I made it 0? And this term I told you to write it directly. Okay. So this, I hope you remember this, what is this term stand for? D, this D by capital D1, which is here 2 meter. Just I am going to write in this form, into this Y. This must be equal to this. Okay, I am just not taking minus sign, okay, because I don't need to write the equation. So what I can say, magnitude of this should be equal to this. That means the length of SS2 to S2P must be equal to SS1 to S1P. Or you can say like this must be equal to this magnitude wise. So what is the magnitude of this? D by D1 into Y, and what is the magnitude of this S2P? Is D by D2 into Y1. I have used Y1, I remember, okay. So this is D1 I have taken now, this is D2, okay, and this is Y and this is Y1. If you want I can write. So you should have started from here itself to solve this question, A part. Okay, DD cancel out, and then here you can calculate what is the position Y1 is given by D2 by D1 into Y. D2 here is, okay, 10.1 by D1 is 2 into Y. Y is 0.4. Okay, or you could have written into, okay, centimeter, that will be better.
So d2 will be 10 by d1 is 200 into y is 40. Now everything is in terms of centimeter. You can calculate here 2 centimeter. The position is found to be 2 centimeter. So basically what I wanted you to write that how to write this quickly. Okay. So you should remember these terms and you could equate them. Okay. So what is difference between this one and this last question? There you have to find out the equation. So I have considered the sign also, minus sign here. Here no need, they are equal, magnitudes are equal. Okay, got it? Okay, so this is the first part we have solved. Second part, now a liquid is poured into the vessel and filled up to Q. The CVF is found to be at Q. Calculate the refractive index of the liquid. Okay. So now if it is filled up to this height, again we'll come back to this and let's see that its P is found to be here, Q. Okay. So I'm just going to draw a dotted line. I just remove this because you have already solved this part, and then here. Okay. Now you know that after pouring this liquid here in this case, okay, the path length is still same because CVF is found to be Q. So we'll use the same concept here. What is the path length over here? Okay. So this is same thing, this and this one, same path difference. Nothing has changed because water is poured here in this case. So you can think like this that the path equivalent this SS2 like I have written here plus S2Q. So S2Q is actually this path is inside the fluid or any liquid, that is we have to find out the refractive index. So equivalent optical air path, okay, this is S2Q is in liquid, this is in liquid say. To find out, okay, what is equivalent air path, okay, or optical path, any word you can use, air path or optical path, S2Q in air, it is mu times S2Q, correct? Mu times S2Q, which I have already explained. So this will be mu times S2Q. So we have written this part, usually like this one, minus, okay, and again this one minus S2P, okay. So what is S2P over here? SS1, which is in air, plus S1Q. Here no need correction. Why? Because this is both are in air. You can have a look at the diagram in this case. Again I'll take this as 0 and this equal to this. So we got the value of SS2, okay, equal to this. So SS2 plus mu times S2Q, I'll keep in this in bracket, okay, equal to SS1 plus S1Q. We'll bring this terms here, SS2 minus SS1, okay, equal to this term mu SS2 minus SS1 is S1Q minus mu times S2Q. Okay. So we will think in this way. Now this is the way to write in the terms of equation, but as I told you that you have to equate their magnitude. So you could avoid all these steps, but just to illustrate that, I just use this mu into S2Q. So you can check like this that this length overall, this must be equal to this one. Directly you could have written like this. Have a look. So no need to write all this thing. Directly you should have written like this. SS2 in air plus S2Q in air is this equal to SS1 in air, and S1Q is also in air. They are equal because path difference. Okay. Now to find out mu here, okay, you know that what is the value of SS1 and SS2 in this case? You can have a look. Anyone? Okay. Just one point you need to think, and then this question is solved. I'm giving you a hint. Okay. SS1 and SS2, okay, this slit is very, very small. Okay. The slit is very, very small. In reality, they are this much. Okay. You can say, and this one is here. So this is SS1 and this is SS2.
Okay, so think about this. Okay, this part difference should be equal to this terms. Now think about similarly S2Q and S1Q. Okay, and hint is that they are on the midpoint, so you can understand what is their length. So here is the modified diagram of this, okay, so that you could understand here, okay, what is S1Q and this is S2Q. You can have a look. They are equal. You can use that to find out, okay, the value of mu. So solve this. SS2 minus S1, you know that what is the value? You know that value equal to, okay, S1Q minus mu times S2Q. Okay, complete it and show it to me. What is the answer you are getting? You can type it over there. Okay. Okay, so mu is 1.0016. Yes, Parv, you are right. Okay, since Parv has given the answer, so I'll tell you the answer over here. Okay, chalo. Okay, so mu times S2Q, which I'm going to write this as D2 D1. I think I have taken as D1, this is D2, okay. So S2Q D2, or should I write this as, okay, mu into D, okay, distance D, S2Q, you can calculate this one, this is D now then, this is D which I have written, so this D is 10 centimeter, minus, okay, SS1, S1Q I mean, which is D, okay, S1Q is D. So you can have a look that this distance 10 centimeter compared to this 0.4 millimeter, this length is considered to be D only. Otherwise you will say that no, S1Q is not equal to this. Of course, here if you find out, if you wanted to calculate what is real value of S1Q, okay, it is not D, which I have taken here as D, okay, S2Q I have taken as D, S1Q I have taken as D, but reality you can see the diagram, it is equal to under root 10 centimeter square plus, you can use Pythagoras, this is 10 and this is 0.4. So 0.04, why? Because this is given in millimeter the whole square. This term will become more or smaller. So compared to this, this is almost equal to 10. So I have explained that why I have taken D in this case. Equal to SS1 minus S12, SS1 minus SS2. Magnitude of this is how much in this case? We want to calculate the magnitude is D by D. In this case I am writing here as D2. Okay, if I am writing this as D1, this as D2, which is 2 meter, into Y. So this formula you remember, okay. Before this arrangement, okay, the path difference is given by SS1 minus SS2. Here I am taking SS1 and minus SS2. SS1 is bigger than SS2, clearly looking at the diagram. Okay, so here magnitude will be D by D2 into Y, which will make it mu D1. D1 you know that what is the value of that. Okay, 10. 10 I am taking common. 10 centimeter mu minus 1, correct, equal to small d, which is 0.8 by 10, because this is in centimeters, so I am keeping this as centimeter, by d2, which is in meter, okay, 200 into y is 40. Okay, So this 45 ja 0.1 okay 0.8 by 50. Okay, so this will be 10 into mu minus 1. Like you can write this as 0.16 by 100 also. So they become 0.0016 divided by 10. One more 0 will be there. So mu minus 1 is 0.0016 plus 1, not plus 1 here, one more 0. So mu is 1.00016. Check the calculation. I think this must be 10 centimeter. This is in centimeter. This is also in centimeter. So I have converted everything into centimeter. Okay. 8.8 by 100. 0.8 centimeter. Okay. So let me check what is the answer. 1.00. I'm getting one more 0. You can check, maybe some minor mistake. You can have a look. Oh. All right. Here is a mistake. Okay, so this is the answer. So you can see that how simple this question was once you remember this basic concept. Before and after the arrangement, the part difference, if you memorize this, you can solve any question very quickly, remembering that optical path length is given by mu into path length in given medium. So mu into given medium, this will be the value S2Q. Okay. So if you wanted to know what is the S2Q in air, multiply this by mu into S2Q in water or any fluid, you will get the value like this. Okay. Any other question based on that you want to ask? Okay. Next one. These are advanced level question, but up to some, to solve advanced level question, you know that some key point you should remember, which I am stressing on those points. Optical air path is very, very important. Okay, so understand that concept. Okay, next question. Okay. Now after solving this question, you will find it easy. Otherwise, if I am giving it directly, it would have been very difficult for you. But here, just have a look. This is S1, S2. This slit is covered. Okay. They have mentioned this as Y axis. This is the midpoint. This is X axis. This given name is mu liquid. This is a glass slab having thickness Tg, T thickness of the glass, and mu G, refractive index of the glass. Okay, and they have covered both slit now by some fluid, which they have given refractive index as mu L. This is D, because this screen,
D is mentioned here as 1 meter, and this a small d. Okay, here parallel rays are coming. A small d is given as 2 millimeter. So this is the diagram. Okay, I am going to write the question. In a modified, why modified? Because in real YDSE experiment only air is used, no other fluid are used in this case. In a modified YDSE, the region between the screen, the region between the screen and slits is immersed in a liquid whose refractive index varies with time. So here refractive index of mu L keeps on changing with time as mu L equal to 5/2 minus T/4 until, where T is variable, time, until it reaches, I think this would have used small t here, but anyhow, reaches a steady state value of 5/4, not of 5/4, value 5/4. A glass plate of thickness 36 micrometer and mu glass, refractive index of glass, as 3/2 is introduced in front of one of the slit, one of the slits. Okay, A. To find out here, A. Find the position of CVF. Find the position of CVF. Find the position of CVF as a function of time. As a function of time when it is at point O. It's mentioned that when it is at point O, so I will just mark it here, when it is at point O. B. What is the speed of CVF when it is at O? When it is at point O, same thing here. So you can solve this question. Okay. So now we'll take less time, I believe, because many terms you know how to write it directly. Okay, solve it now. Yeah, here capital T, okay, is time. Okay, that time I mentioned that they should have given small t, maybe misprint. So here t is time, which is variable. It's not a fixed time. Yes, you have to find the speed as a function of time. And later you can substitute the time t that you got in part A. So first, for part B, first find out what is the velocity as a function of time t, and later you can substitute t by a value which you got in part A. And this is one of the best mixed question where refractive index also changes, slits is there, fluid is there. I mean, all the questions are included to this. All the possible scenario is included to this. You must try that. Five into 10 raised to power minus 3. Let me check, Sanjeev, your answer is right or not. 4 minus t by 10 minus t. Yeah, you are right, Sanjeev, your answer is right. Good. So once you have understood that point, I told you optical air path, it's not so difficult to solve this question. So I'm going to discuss this question and though they have asked what is when the CBF is at O, but still I will tell you by taking a point, since glass slab is inserted over here. So I'll consider another point, not O, P, which is at distance Y, because I want to correlate that. So once you introduce the glass slab over here, the CBF will shift to point P, which is distance Y. So just join this. I should have taken a little more down so that it doesn't seem that it is in front of this. So this is P, this is Y. Okay, that's all right. Okay, so don't get confused. After taking Y equal to 0, this will reach to point O, okay, which is the first question, part A we have to solve when this P is at O. Okay, so here if I am giving, I wanted to calculate delta X in this case, part difference. You can check that S1P is in fluid, okay, or liquid, anything you can write. So that is equivalent to mu liquid into S1P in air. Okay, you don't need to write all these things, just I am telling like this. So we can calculate like this. We will write the part difference of this in liquid, okay, just after this. So it is coming out to be, okay, S1P as mu L into S1P in air. Similarly here S2P. S2P in liquid, S2P minus. You know that here overall length is S2P minus TG, T glass, okay, in liquid plus, okay, T glass. This is the length, okay, you can think like this. This is this path S2P, this S2 minus, okay, that is in liquid, S2 minus T, S2P minus T, that is in this fluid. So what part is in fluid? You can say that remove this thickness TG and then it will remaining are in the liquid. So this is the part which is in the liquid, S2P minus TG, and this is TG also in liquid. So if you want, you can write this as also liquid. Okay. So we know that what is in air. So it will be mu liquid, like I have written, into S2P minus TG in air. It's just a notation. Don't get worried about this. Just a notation. To change in liquid, I'll just multiply mu L. Okay, and then I'll tell you which step you should have written directly, not all this. Plus, okay, TG in liquid will be mu G. In air, if you are going to keep this in